All right, here's page 2 of the trig equations worksheet where we're asked to find solutions that fall in this range right here. Page 1 I did in a different video. For this video I'll start with number 5 here. You're given this huge mess. You might think you should factor. In fact, you should factor. I even give you the hint. I say factor, but I tell you to factor by grouping. First thing, don't factor unless it's set equal to 0. So subtract 3 from both sides of the equation. You got 8 sine cubed x plus 4 sine squared x minus 6 sine of x minus 3 equals 0. And now you factor by grouping. The way you factor by grouping is you form these groups and look for the greatest common factor of our first group. Well, they both have a 4 sine squared in them, so I can factor out 4 sine squared x. And what I would have left behind from this term would be 2 sine of x. And from this term would just be 1. And so now my goal is to factor something out of this group so that I'm left with 2 sine of x plus 1 in the parentheses. Well, if you factor out a negative 3, you'll be left with exactly 2 sine of x plus 1 in the parentheses. And so now I have two terms, and each of those terms have 2 sine of x plus 1 in them. So I can factor out that common factor of 2 sine of x plus 1. This is now gone and this is gone. What's left behind is 4 sine squared x minus 3. That is what's called factoring by grouping. The nice thing is that now I have a factored form. I have two numbers multiplied together, this and this, that equals 0. That can only happen if 2 sine of x plus 1 equals 0, or if 4 sine squared x minus 3 equals 0. Solving this one, let's subtract 1 from both sides of the equation and divide by 2. And then think about your unit circle. Where on your unit circle, what angles have a y-coordinate equal to -1/2? I think we've done that one already on the first half of this video. It's 7 pi over 6 and 11 pi over 6. What about this guy? Well, add 3 to both sides of the equation. Divide by 4. And take the square root of both sides of the equation. Make sure when you take a square root, you put in the plus or minus. The square root of 3/4 is the square root of 3 divided by the square root of 4, which is root 3 over 2. So now think about where on your unit circle is the sine of x equal to either plus or minus root 3 over 2. Well, that's going to happen a bunch of places. It's going to be equal to positive root 3 over 2 at pi over 3, and then again at 2 pi over 3. It's going to be equal to negative root 3 over 2 at 4 pi over 3, and again at 5 pi over 3. So I actually end up with 6 solutions in the specified range for this problem here. All right, moving on. Cosine of 2x plus sine of x equals 0. This one's tricky because you have cosines and sines, which makes things challenging. And furthermore, we don't even have cosine of x and sine of x. We've got cosine of 2x. How am I going to deal with that? Well, I have these formulas at the end here, these double angle formulas, that tell me that the cosine of 2x can be written in any of these three forms. So which one should I choose? Well, if you go back up to the problem here, you'll note that the other term is in terms of sine. So if I could rewrite cosine of 2x just in terms of sine of x, that would make life easy. Cosine of 2x is equal to 1 minus 2 sine squared x. So instead of cosine of 2x, I can write 1 minus 2 sine squared x plus sine of x equals 0. And now what I have is a quadratic trinomial. What I would probably do is add 2 sine squared x to the right-hand side so that my leading coefficient is a positive number. And then subtract sine of x over to the other side, and then subtract 1 over to the other side to get here. And then I would try to factor this guy. You could do this using the 3-step, I guess, process that I described up here in number 3. Or with numbers this small, you might be able to just guess and check your way into it. Because 2 is a prime number, the only way I can get there is with the 2 and with the 1 is the coefficients on the sine of x. Negative 1 is also prime, so I'll have to put a positive 1 somewhere and a negative 1 somewhere. And in order to end up with negative sine of x, I better make the negative here and the positive here so that when I FOIL, I get negative 2 sine of x and positive 1 sine of x, which nets out to the negative 1 sine of x. At any rate, either the longer method or the guess and check method you get here, and now I can say, all right, 2 sine of x plus 1 equals 0, or sine of x minus 1 equals 0. Subtract 1 from both sides. Divide by 2. And think about on your unit circle, where does the sine of x equal negative 1/2? Sounds familiar, I just did it right here. Assuming I didn't screw it up in red, it must be 7 pi over 6 and 11 pi over 6. And over here, we're trying to figure out when does the sine of x equal 1. Well, that only happens at one spot, at x equals pi over 2. So I get as my solutions, there's actually 3 that fall in the 0 to 2 pi range. But box around those and call it good. This one, oh man, this one's a mess. Cosine of twice something equals this guy. What I was hoping people would recognize, and frankly, you can kind of assume this one's extra credit. This one's a pretty hard one. Not that you get any credit for this worksheet anyways. Is to use the double angle formula. The cosine of twice something. You should use a double angle formula. Well, here's my double angle formulas. I got 3 to choose from. Which of these should I choose? Well, what's going to be on the inside will be arcsine. So if I could choose one that was in terms of sine, the sine and the arcsine will cancel out nicely. In other words, the cosine of 2 times some angle is 1 minus 2 sine squared of that angle. So I can rewrite this guy as 1 minus 2 sine squared of the angle. The angle in this case is arcsine of x. Turns out the sine and the arcsine cancel each other out. If you have trouble seeing why that works, let me show you. Is because when you write the squared here, really what you mean is sine of arcsine of x squared. It's written here to try to make it less ambiguous of what you're trying to square, but this is what it means. And the sine of the arcsine of x is just x. I get 1 minus 2x squared is equal to 1 minus x. And now I can try to solve this guy. I don't know, subtract 1 from both sides of the equation. And I could add the 2x over to this side and get 0. Sorry, add the 2x squared over to this side. And then I would have 0 equals 2x squared minus x. Let's hop up here. Factor out an x. And I get 0 is equal to x times 2 minus x. And so I get x equals 0 or 2 minus x equals 0. So either x equals 0 or x is equal to 2. So it might appear that there's 2 solutions here, but I think only one of them will end up working. If you try plugging in, this won't check. What do you mean that won't check? Well, if I put x equals 2 in here, what I'm trying to figure out is what is the arcsine of 2? The arcsine of 2 is asking you the question, what angle, when I take the sine of that angle, gives me 2 as the answer. Well, sine has to be between -1 and +1, so it can't possibly happen. The arcsine of 2 is undefined, so this answer won't check. I think this is the only solution to this problem. The arcsine of 0 is 0 because the angle 0 has a sine height of this 0. And 2 times 0 is just equal to 0. And the cosine of 0 is equal to 1 because it's saying what's the x coordinate at an angle of 0. So this side ends up being equal to 1 and 1 minus 0 is 1. This one checks, this one doesn't. That's the only solution. This one is challenging. It's modeled off a homework problem. The idea here is to recognize that there's a tangent squared x in each of these guys. So I got tangent to the 4th x minus 9 after I factor out the tangent squared x. Now I got something times something equals 0. You could set them both equal to 0 at this point, or you could factor further. This one's kind of hard to factor, but it turns out that that's a difference of squares. The tangent to the 4th of x is a perfect square, and 9 is a perfect square, and I'm taking the difference of them, so it factors as conjugate pairs. Takes me here. Now I got something times something equals 0. That can only happen if one of those things equals 0, either tangent squared x equals 0, or tangent squared x plus 3 equals 0, or tangent squared x minus 3 equals 0. Well, let's see. If I take the square root of both sides, I get tangent of x equals 0, and that happens when x is equal to 0 or when x is equal to pi. Over here, I'd get tangent squared x equals -3. You might already have a problem with that. How am I going to square a number and make it equal to a negative number? There's no solutions there. That's true. Or take the square root of both sides, take the square root of a negative. no solutions coming from this factor. But this guy, I got tangent squared x, if I add 3 to both sides, equals 3. And so tangent of x equals plus or minus the square root of 3. That's going to lead to all sorts of solutions, because the tangent of x is equal to the square root of 3 at pi over 3. And it's also equal to the square root of 3 at 4 pi over 3. But it's equal to the negative of the square root of 3 at 2 pi over 3. And also at 5 pi over 3. So I get all these guys as my answers. A little note here. Actually, let me put a box around those first to make it clear that that is my answer, or my answers. The problem off the homework from which this was based asks you to enter the answer in a weird way. If I wanted all solutions, I could say it's 0 plus or minus pi k, pi plus or minus pi k, pi over 3 plus or minus pi k, 2 pi over 3 plus or minus pi k, to follow the same outline I did up here. Note that now it's pi k, not 2 pi k, because the period of tangent is just pi. So I could say that. I could also say that it is just multiples of pi over 3k, or of pi over 3. So if I wanted all solutions, I could say it's something like this. It's any multiple of pi over 3. Here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3 would be 2 pi. If I wanted all solutions, I could type it in like this. On a quiz, I'll ask it in the red way. On the homework for this specific problem, it asks it in the blue way. I think it asks you for what number times pi k is the answer. And so your answer would be 1/3 for this problem. Okay, a couple more to do here. This one is kind of a mess using the half angle formula. So you got the cosine of x plus, and then instead of cosine of x over 2, go down here and say, well, cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine of x over 2. How are you going to deal with a plus or minus in here? Well, my hint was ignore the plus or minus for now, and then just check the answers at the end and make sure that you account for everything. So fine, make it positive. How are you going to get rid of the square root? Well, I would subtract the radical to the other side of the equation so that I can square both sides of the equation. And that'll take me here. Note that if I square a negative, it turns positive and the square root cancels out. So what do you do from here? Well, it's going to be a quadratic trinomial. I'm going to set this thing equal to 0. Maybe first multiply both sides by 2 so you don't have to deal with fractions. And then subtract everything to one side of the equation so that it's set equal to 0. And then factor this guy. I think I've already factored that guy. That's exactly this, right? Except with cosine instead of sine. At any rate, it'll factor into 2 cosine of x and cosine of x. And I better put the -1 on this side and the +1 on this side to get everything to work out. So either 2 cosine of x plus 1 equals 0, or cosine of x minus 1 equals 0. So either cosine of x equals -1/2, or cosine of x equals 1. And so where does that happen? Well, cosine of x equals -1/2 at 5 pi over 6 and 7 pi over 6. And cosine of x equals 1 at 0. And then I say check your answers at the end, so try plugging those in. The cosine of 5 pi over 6 is -1/2. The cosine of half of that, well, half of that would be 5 pi over 12. And 5 pi over 12, if I take the cosine of that, I am not going to get +1/2, which is what I would need to get to make the sum of those two things equal to 0. In other words, this answer is not going to check, nor is this answer. I'm even going to write only this checks. So that is my only solution. Ends up being right. I paused this just so I could think about it for a minute. 2 pi would also work, because cosine of 2 pi is 0, and the cosine of half of that is pi, the cosine of 2 pi is 1. And the cosine of half of that is the cosine of pi, which is -1, and the sum of those is 0. But I don't list that as a solution because I only want answers between 0 and 2 pi, not including 2 pi. So that is the right answer. Last one here, sine of x plus 2x. Hint, use the angle addition formula. Oh, because it's something plus something, okay. Then the double angle formula, oh, because I'll have a 2x in there, okay. Man, that's going to be terrible. Is there an easier way? You bet there is. Quite a bit easier. X plus 2x is just 3x. So all you're trying to figure out is when is the sine of 3x equals 0. Well, that'll happen when 3x is equal to 0. But it's also going to happen when 3x equals pi, or 2 pi, or 3 pi, or 4 pi, and so on. Right? The sine of any of these angles equals 0. But wait, I thought you said the answer should be between 0 and 2 pi. True, the answers for x should be between 0 and 2 pi. So I need as many of these. I'm going to divide them by 3 in the next step. So I need to include more than just 0 and pi. Because when I divide them by 3, I'll get pi over 3, and 2 pi over 3, and 3 pi over 3, 4 pi over 3, and 5 pi over 3. And now I can stop because the next one will be 6 pi over 3, which is 2 pi, which is not between 0 and 2 pi. So these are the only solutions. If you're going to skip 2 of them, skip 10. If you're going to skip 3 of them, skip 9, 10, and 7. Those might be a bit beyond what I need you to be able to do, but I'd like you to be able to solve the rest of these as far as the final exam. So hopefully this video aids in that goal. I'll call this good.